Hey there, wonderful. So this is Miss Lawrence, and I'm going to be walking you through some things this week. And we're going to go ahead and we're going to talk a little bit about changing linear equations. And specifically into slope-intercept form. Okay. So the slope-intercept form, I'm going to go ahead and I'm going to highlight it here for you. The slope-intercept form should be exactly what you were working with last week. So if you remember from last week, or maybe some point, doesn't actually have to be last week, maybe some point in your algebra career, slope-intercept form looks like y equals mx plus b, where m is representing your slope and b is representing your y-intercept. And it was super easy to go ahead and graph from these guys because you started at your y-intercept and then you used your slope. But sometimes it's not in that form. It's not in that form at all. So I'm going to talk about a few examples here, and then we can hopefully see that you can change any linear equation into slope-intercept form. So for example 1, I'd like to start with 3y minus 12x is equal to 9. Now, this is a linear equation, and the reason that I know it's a linear equation is because it has a y and an x and no exponents. So for this one, linear equation, we just know that it's not in slope-intercept form. So it does not look like y equals mx plus b. However, this is going to be our goal to get to. So we're trying to get it to that. And if you'll notice here in this form is that the y is isolated. And isolated, there we go, really just means to get by itself, right? So you're trying to get that y by itself. If you'll notice here on our y over on our example, there's a few things that are going on. It has a 3 in there, and then a negative 12x. So we're going to need to use our inverse operation. So I'm going to go ahead, I'm just going to kind of star this over on the side. Maybe I'll even switch colors to pink. All right, so we need to use inverse operations. And those inverse operations, if we remember, are the opposite of what's going on. So I want you guys to go ahead and just kind of listen to this part right here. So I have 3y minus 12x. Now I said minus, so I need to go ahead and need to do the opposite of that. The opposite of minus is plus 12x. Now if you'll see here, the whole reason that we did this is that we have this, that's not the right color, sorry. There we go. Negative 12x plus 12x, this is going to cancel out, leaving us simply with that 3y is equal to, now I like to keep the x's in the first part of my equation. So y equals 3x plus 12. And again, those inverse operations. So I always like to say the equation out loud. You can say it out loud. Nobody's around these days. You can say it in your bedroom or wherever you're doing your homework. So we have 3 times y. Remember, when it's next to a variable, it means times. So 3 times y. And if it's times, ooh, my iPad was freaking out. It's times, that means we need to divide. Remember that little fraction sign means divide on that. So we're dividing, and if you divide one thing, you have to divide everything. So 3 divided by 3 just leaves you with that y. So y is equal to, let's go ahead and reduce this 12 divided by 3. That's 4x plus 3. Now it looks like slope-intercept form, and we can pull out some information from this guy. I know that my slope is going to be 4. My y-intercept is going to be at the point 0, 3, and now that I have this bit of information, I'm able to graph it. So I'm going to set up my axes here. I have kind of a nice little feature here on this iPad that makes the straight lines for me, but you can use any straight edge that you'd like to draw these lines. Now we're starting at the point 0, 3, so go ahead. I like to see that nice big dot right at your y-intercept. And then using a slope of 4, you go up 4 over 1. Oh, I kind of ran off my axes here, I'm sorry. But the cool part about the slope is that, of course, you can go down 4 and to the left 1 to get that kind of upward line. And now that I have these 3 dots, I like to use 3 of them. There we go. I like to use 3 so that they line up nice and easily. And again, I have this nice feature that draws these straight lines, but feel free to use any straight edge. Okay, and that is the line. And this is the line, so this is the same exact line. 3y minus 12x is equal to 9. Or we can also write it as y is equal to 4x plus 3. Either one, they mean the exact same thing. They look different, but they mean the exact same line. Okay, so now let's go ahead and work with example 2. So I'm going to switch colors here. I'm going to scroll up a little bit. I don't want to leave too much. There we go. So example 2 for you. So 5y plus 10 is equal to 2x. Now this one looks a little bit different than that other example. However, we still have the same goal. So I'm going to keep that kind of green color. And our goal is to get to y equals mx plus b, meaning that that y is isolated. So you can go ahead, you can either take a pencil and underline y, just to remind yourself that everything else on that side of the equation, so the 5 and the 10 are going to have to move. So let's use those inverse operations. If we say plus 10, that means we have to minus 10, leaving us with, we have 5y, that plus 10 minus 10 goes away. And again, leave this x out front so that you can see your y equals mx plus b form. So this is so close. So close. But if you were see here is that this 5 is kind of attached to the y. So it's not mx plus b form yet, meaning that we need to divide by 5. And if you divide one thing by 5, you have to divide everything by 5. I'm going to say that one more time. If you divide one thing in your equation, you have to divide everything in your equation. Okay, so this fraction over here, this 2 over 5, cannot reduce, so I'm just going to keep it. So y equals 2 over 5x. However, this negative 10 over 5 reduces to negative 2. And now we've reached our goal that y is isolated and it looks like y equals mx plus b, meaning that my slope is 2 over 5 and my y-intercept, or b, is the point 0, negative 2. And now we are going to graph it because we're all set up to go. So again, I'm setting up my axes. And this guy over here, now I'm going to have to go a little bit farther because I got to go over 5. All right, so there we go. There's my axes. I'm going to switch back to purple so that we keep it matched up. I'm going to make that y-intercept. That's the very first thing that I like to do, just to make sure that the y-intercept is good to go. And now I'm going to actually switch over to some highlighters so that you can see how this works. Do a different color. This guy. I like to move up 2 and then to the right 5. And there's my next point. All right, so from here, I go ahead and I make that point on the line. Now you can also go down 2 and to the left 5 to make a third point. You only need 2 points, but again, I like to have 3. From there, please use a straight edge and go through the line. If you'll see here, the highlighted point's not my line. The purple part is my line. The highlighted part was just to show you how to do the slope. And that's all there is to it for that guy. You just wanted to go ahead, you wanted to move some things, and now you can graph your line. Okay, I have one last example for you. Let's choose orange. Orange is a good color. So I have example 3. And the reason that I'm showing you this guy is because this can get a little bit tricky when you have this fraction in here. So y minus 1 over 2 is equal to negative x. Now, there's a few different ways that you can think about this guy. I like to think about it as fraction busting. So I like to go ahead and I like to multiply everything by 2. And anytime that you have a 2 on the denominator, that just goes ahead and it cancels out. So the only thing left here on the left side of the equation is y minus 1, but you of course have to multiply this negative x by 2, so negative 2x. Okay, now that all the fractions are gone, now we can still go ahead, we're going to isolate that y. That's our goal, to get y by itself. So y equals, keep the x's out front, so negative 2x, then put the rest of the equation on there. So plus 1, and that looks exactly like y equals mx plus b, meaning that my slope is negative 2, and my y-intercept is the point 0, 1. And from here, we're all set up to graph. I'm going to graph this on the side so that we keep it all on one piece of paper. There we go. And then I'm going to set up my x-axis. Okay, again, I like to start with that y-intercept because the y-intercept you can just get done and over with, and that's your starting point. Okay, so now from my y-intercept, it's a negative 2. I'm going to switch over to those highlighters again so you can see what I do with this guy. So I like to go down 2 and then over 1. So again, and from here, I can make a point, but then if I use that highlighter to show you what I do, I go down 2, over 1. And again, use your pencil to make a point. As a reminder, the green part is not part of my graph. Once again, that green part's not part of my graph. The graph is just the orange part. And now we're able to draw a line through all these points. It's a negative slope, so I'm going to check on a few things. My negative slope here means that I'm going downhill. And yes, I am going downhill for my guy. And my y-intercept means that I'm starting at a positive 1, so my line looks good there. Very nice job, and hopefully you ace